Hi and welcome to this video on simplifying radicals with exponents. Maths made easy. Well, this isn't so easy to follow as I go through. Try and follow it as I go through. I'm going to go through some techniques and explain them to you and why we do it. And then right at the end, if you work through the examples yourself, I think everything should fall in place. So what do we mean by simplifying radicals with exponents? So when we're simplifying these, what we're trying to do is get rid of the square root sign and or reduce this exponent. So first of all, square root, we have a little 2 on the outside of the root sign. That it signifies that that's square root. Square root of x squared is x, or x to the power 1. Square root of x to the power 4 is x to the power 2. Square root of x to the power 6 is x to the power 3. If we want to double check that, what's the opposite of square rooting? It's squaring. So if we square x to the power 3, we multiply the 3 by 2, and that gives us 6. So we got x to the 6 here, so we know we've done that right. Here we've got the square root of x to the power 3. How do we do that? Well, look at this pattern that we've done here. 2 into 2 goes once, 2 into 4 goes twice, 2 into 6 goes 3 times. So here we go, 2 into 3 goes once, so we have x to the power 1 on the outside, and we've got x to the power 1 left underneath the square root, which we can't simplify further, so we leave that as it is. So x cubed square root simplified is this. Also, if we've got square root of 12 using our property of surds, we can simplify that to square root of 4 multiplied by square root of 3. Square root of 4 is 2, and square root of 3 we can't simplify further, so I'll leave that as it is. If we forget how to do this in the exam, we'll go totally blank. Another way of doing this is this way, which is finding the prime factors of 12. Prime factor of 12, 2 and 6. Prime factors of 6, 2 and 3. And this pair of numbers gives us our square root of 2 multiplied by 2 square root of 4. And the single number gives us this 2. So 2 and this 3 is the square root of 3. So 2 square root 3. Okay, let's use this technique on this square root of x to the power 5. So 2 into 5 goes twice, so x to the power 2 on the outside. We've got 1 left over, which we can't simplify further, so that remains as square root of x to the power 1. 2 into 7 goes 3 times, y to the power 3 on the outside, which is here. We've got a y to the power 1, which we can't simplify further, so that remains underneath the square root, which is here. If we combine these results, let's just do this one here, which is square root of x to the power 3, y to the power 5z. 2 into 3 goes once, so that's x to the power 1 on the outside. And then we got x to the power 1 left underneath the root, which we can't simplify further. 2 into 5 goes twice, so we can take that out. Y to the power 2 on the outside. And then we've got y to the power 1, which we can't simplify further, so leave that underneath the root. And this z by itself we can't simplify further, so leave that under the root. There we go. Square root of 32, we can simplify that as square root of 16, which is our square number, and square root of 2, which we can't simplify further. Square root of 16 is 4, and square root of 2 remains as it is. Then we can carry on. 2 into 5 goes twice, so x to the power 2 on the outside and x to the 1 leave it under the root. 2 into 4 goes twice, y to the power 2 on the outside. 2 into 14 goes 7 times, z to the power 7 on the outside. If we forget to do this, or how to do this in the exam, again we can do it this way, using our prime factors. Prime factors are 32, 2 and 16. Prime factors 16, 2 and 8. Prime factors of 8, 2 and 4. Prime factors 4, 2 and 2. And this pair of 2's and this pair of 2's gives us this 4. And this root 2 remains as it is, 4 root 2. Okay, we've done it using square roots. Now let's do it with any root or a cube root. So cube root, put a little 3 on the outside, or They should give you a 3 on the outside of the root in the question. If they don't, we take that as a square root and they put a little 2 there. Okay, so 3, we're going to simplify this 16 into our cubic number and a number that we can't cube root. So we have cube root of 8, cube root of 2. Cube root of 8 is 2, and cube root of 2 we can't simplify further, leave that under the root. Okay, so we have this 2 and this 2 under the cube root. 3 into 11 goes 3 times with 2 left over. So x to the power 3 outside, x to the power 2 remains under the root. 3 into 15 goes 5 times, y to the power 5 on the outside, nothing left underneath the root. 3 into 20 goes 6 times with 2 z to the 2, which we can't simplify further. So z to the 6 on the outside, z to the 2 remains underneath the root. If we forget how to do this, simplify the cube root of 16, then we can do the prime factors. Prime factors 16, 2 and 8. Prime factors of 8, 2 and 4. Prime factors 4, 2 and 2. And this 3 2's gives us our 2. And this 2 that remains is our cube root of 2. So here we've not been given a number, we don't know, there's no 3, 4, whatever on the outside of the root symbol, so we take that as square root, take that as a 2, leave the 4 on the outside, 2, simplify this root 12 into root 4, root 3, then 2 into 5 goes twice, x to the power 2 on the outside, x to the power 1 on the inside of the root, 2 into 4 goes twice, y to the power 2 on the outside, and this z we can't simplify further, remains underneath the root. So this becomes 4, the square root of 4 is root 2, this we can't simplify further, so this remains underneath the root. If we have our radicals with exponents as denominators, we need to get rid of that because they're quite difficult to work with. So if we're given a simple one like this, we multiply by root 4 over root 4. Essentially that's 1, so leaving this fraction as it is, but we've made it simpler to work with. Root 4 times root 4 is 4, and 5 root 4 as the numerator. So this is easier to work with in calculations. If we're given this form where we've got the root cube root of 4, then we need to make this power into a 3 so that we're left with a 4 when we cube root it. So this then is what we have to multiply with. The numerator and the denominator have to be the same, and the denominator we have is the cube root of 4 to the power 2, so that when we multiply it together we get cube root of 4 to the power 3, okay, which is 4. In this case we're doing something similar, so we got y to the power 1 as a denominator, going to multiply with this with the cube root of y to the power 2. When we multiply that together we get the cube root of y to the power 3, and that is just y. In this case we got 3 to the minus root 2. Here we have to multiply by the conjugate. The conjugate, we reverse this sign, so that becomes 3 plus root 2, and then we have the same thing as the numerator to make this equal to 1. Okay, in this we're going to simplify this whole lot square rooted. So first of all, let's go through this and try and simplify this before we get rid of this square root. So 50, look for a square number, so 25 times 2, this is our square number, and this is our other factor that we have to multiply by to get 50. 12, the square number is 4, multiplied by 3 gives us 12. Then x to the power 8 divided by x to the power 4 gives us x to the 4, 8 minus 4, x to the power 4. Y to the power 3 minus, when we divide with minus, y to the power 9. So that becomes y to the minus 6. So we have 6 as the denominator. So this essentially is y to the minus 6. Z to the power 10 divided by z to the power 4. So 10 minus 4. When we divide, we minus the exponents. So 10 minus 4 is z to the power 6. Now we can try and get rid of this square root sign. So square root of 25 is 5. Square root of 4 is 2. This 2 we can't simplify, and this 3 we can't simplify, so leave those as under the root. Square root of 2, square root of 3. This x to the power 4 becomes x to the power 2 when we square root it. Z to the power 6 when we square root becomes z to the power 3. And y to the power 6, y to the power 3 when we square root that. We've got this square root of 3 as the denominator, so difficult to work with, so let's try and rationalize that. So we multiply by square root of 3 over square root of 3, and we get this. When we square root something and we're left with an odd power, we have to use these absolute value symbols. So z to the power 3 within absolute value symbols, y to the power 3 within absolute value symbols.